Hello, it's Helen, and I continue to the last video on the EDA and data cleansing. This video I will talk about the model selection for Alzheimer disease. So I will use PKRS and scikit-learn. So firstly, we look at PKRS. The version I use is 3.9 and here's the data set. Now we have 350 rows and 9 columns. So we can have a look at the data set here. I check again for unknown value to make sure that everything good, and after that I set aside the unseen data so that we can test it with on the model I built later on. After setting the unseen data, I will set up the data before building model. Look like there nothing changed to my transforms data except for the group. So now we have 1 for demented group and 0 for non-demented group. So here on the model we can look at, and I've been changed a different subset of the data and change the features, and after on I got a very high score. So there's some reason for those high score, and we will look at on the model later on, but I want to explain it from now. So firstly, I think because on the model took the CDR, like the clinical dementia rating, to like the most important features for all the models I'm choosing. So because that model, that features have a high correlation with the outcome, like the group. So that's maybe one of the reasons why it have the high score. The second thing is that my data sets only have 250, so it's quite a little bit small for the data we look at. But for the healthcare and this kind of disease, I think that's pretty good for now. So I tried different kind of models and I decided to keep 6 of them to introduce here. All of them have the F1 score around 98%. So firstly we look at Rich. So Rich model is have only one wrong prediction and the feature important. Yeah, the CDR is very important, and also take 2 other one into account. The second one is the light GPM. Light GPM also have the same 98 something percent, and yeah, also CDR and the MMSI have a little bit more important. Let's see, yeah, it's also gets one wrong, like the person without dementia, but it's predict like dementia. LDA is the other one. So the LDA we also have kind of 98 is the norm here, and it's considered CDR and the brain volume very similar. And look at the confusion metric. Yeah, very similar to the other one. One wrong. And on the 3 others, so XG boost, yeah, the same thing, very even higher score compared to the other model. And the XG boost, it took only CDR, like only one main features, and it's not on the other one. H3, yeah, also high score. And look at feature important and confusion metric here. And the last one I look at is the random forest. The random forest have very high score. more than 99%. Yeah, see, they are always the most important features, and a few other one. So after that, I save on the model, and I'm looking at the yellow brick. It's a library under scikit-learn to have a summary with on the model I have and how it's performed. So in general, I have very high score, especially for XGBoost, uh, the actual tree, and the random forest. The other one, like GPM and LDA, enrich a little bit lower, but still very high score. So in my opinion, I will use LDA maybe, yeah, because of the CDR. CDR is a very simple test to measure the cognitive performance of the patient. So this test will not take into account any other background information like age or social economic status, not anything like that, and even not the brain performance on MRIs. So I think it's better to go with a model that can balance all of the features, not only based on one feature like the CDA. And after that, I load the unseen data and load on the model we saved before to test again the unseen data. And for all of my model here, uh, it's performed really well against the unseen data. Yeah, so that's all we have for Alzheimer's disease for the model selection. Thank you.